In this example, we're going to write a quadratic function given these two complex roots. We have negative 4 plus 2 radical 6 over 3i and negative 4 minus 2 radical 6 over 3i. So we know that these functions can be written from their roots, and we can do so in factored form, x minus a and x minus b, where a and b are the roots. And so it's quadratic, so we have two roots, one for each. All right, so let's go ahead and get going. So f of x equals x minus a, which is the first root, so negative 4 plus 2 radical 6 over 3i. And the other one is x minus, and then b is negative 4 minus 2 radical 6 over 3i. All right, so now it's a lot of simplification. So f of x equals, the first thing I'm going to do is distribute these negatives through. So x plus 4 minus 2 radical 6 over 3i, and x plus 4 plus 2 radical 6 over 3i. And what I see here is that I have a difference of squares factorization. I have x plus 4, and then I have this radical expression, and of course 1 is being subtracted and 1 is being added, so that will make a really nice multiplication here. So f of x equals, I just need to take my x plus 4 and square it, and then subtract the square of that term right there. Alright, so we'll slide up and let's go ahead and see what this multiplication looks like. So f of x equals, when I square this little binomial, that'll be nice, x squared plus 8x plus 16 minus, and here we're going to square this. So 2 squared is 4, the square root of 6 squared is 6, and then 3 squared is 9, and then this I squared is a negative 1, which of course the negative 1 and this minus out front will just make a plus. And then let's simplify this a little bit. So we have 4 times 6, and then we have over 9. So I notice I can take a 3 out of each one of those. So let's go ahead and do it. So that'll become 8/3. So f of x equals x squared plus 8x plus, let's go ahead and get common denominators, 48/3 plus 8/3. So my final function, written in standard form, x squared plus 8x plus 56/3. And then of course, sometimes what we do is you can go ahead and change it. If you don't like this fraction to be there, you can just multiply everything by this 3, because you're not changing the roots of the function at all. If you just multiply everything by 3, it's just a scalar product. So let's multiply 3 by everything. So 3x squared plus 24x plus 56. And now there are no fractions, and that's going to be the quadratic function giving these two initial complex roots.